explore the decision boundary of MCP neurons for the AND and OR logic gates. A decision boundary is simply a line that separates the input space into two regions, one where the neurons output 1 and another where it outputs 0. So let's see decision boundary for AND neuron. For the AND gate, the MCP neurons fires only when both the inputs x1 and x2 are 1. Mathematically, the rule is x1 plus x2 greater than equals to 2. This equation forms a straight line in the 2D input plane. The line is x1 plus x2 equals to 2. Graphically, this line lies beyond the point 1, 1. So all the points below this line 0, 0, 0, 1, 1, 0 are classified as output 0. The only point above or on that boundary, which is 1, 1, gives an output of 1. In simple terms, the AND decision boundary is a line that includes only the top right corner point of the input plane. Let's say decision boundary for the OR neuron. For OR gate, the neuron fires when at least one input is 1. And here the rule becomes x1 plus x2 greater than equals to 1. This also forms a straight line boundary, x1 plus x2 equals to 1. This line runs diagonally across the input space. All the points on or above this line 1, 0, 0, 1 and 1, 1 belongs to the output class 1. Only the point 0, 0 which lies below the line produces an output of 0. So the OR decision boundary is the diagonal line that separates the no activation region containing only 0, 0 from the